that we're going to go over today are pretty much test questions. If I saw a question that wasn't a test question, I did two criteria. One, which ones are the ones y'all sending the most? And two, is this a good test question? So the ones that I'm picking are both. So chances are they're going to be on a dadgum. It won't let me join the meeting. How? I don't understand why some people are joining. Hold on, let me see if I can get Miss Blinkhorn in here.
It's the
Russians, Iranians too. Is her name Emily Jo? There we go. Let's let her get in here right quick. I had somebody in yesterday's class saying they couldn't get in. I'm like, I don't understand how that can happen. So hopefully Miss Blinkhorn will get in here. It says it's calling her. Okay, this question says, write the expression in terms of sine and cosine so that there are no quotients in the final answer. Write in terms of sine and cosine with no quotients at the end. So in other words, at the end, you're gonna get something very small. Miss Blinkhorn, did you get in? I don't see her. Let me try her again. Evidently, there's something wrong with her computer or something, because I've got freaking, how many have we got in here? I've got 17 people in here, so something must be working. Okay. And the question says cosine squared theta 1 plus tangent squared theta. Now, the first thing the first rule of identities is to make everything in terms of sine and cosine. So I'm going to change that tangent into sine over cosine. And now I'm going to, okay, Miss Blinkhorn she ain't come in yet. Hold on, let me send her a, I don't understand what the problem is. Have any of y'all had a problem where you can't get in the meeting?
Not I.
Huh. Okay. Now distribute that cosine. And you get cosine squared theta plus cosine squared theta over 1 times sine squared theta over cosine squared theta. And what happens to the cosines? What happened to the cosine squared?
They cancel.
Cancel.
Appreciate y'all's interaction. That gives me cosine squared theta plus sine squared theta. And what is cosine plus sine?
1.
That's why that's a good test question. Short and sweet and to the point. Okay. Miss Blinkhorn, are you here? Miss Blinkhorn, I see your name. Are you here? I don't see her, so I don't know if she's here or not.
Yeah, I'm here.
Okay. Did you find out why your computer was, it must be your computer or your internet. What's going on?
My Microsoft Teams wouldn't let me join. It just said try back in a few minutes, and it wouldn't let me. I would click to accept you inviting me to the call, but it wouldn't let me in.
You might need to reboot your computer.
Probably.
I would suggest doing that because that'll probably fix it.
Or close out any extra tabs.
Yeah. Okay, next question. Now this question is the way they, okay, let me go ahead and tell you. I'm going to show you this question. And I'm going to fold it up where you can't see it because this question is either a new question, but it is not, I don't like the way they have it. They don't have any explanation. It's just like, okay, here, do it. And they don't give you any, I don't like it. So I'm just going to leave it at that. This is the question as it appears on your homework. And it is not, I don't like the question. It's almost like a new question and they haven't finished writing it yet. I don't like this question. It says, complete the table so that cotangent is written in terms of the one with the blank. But the way it's written, it confuses a lot of students. So basically, you got to write cotangent in terms of sine, in terms of cosine, and in terms of cosecant. So it seems like to me the best way to do that would be just to ask you to write it in terms of sine, cosine, and cosecant. But that's just me. So I'm going to take this off again. I'm going to rewrite cotangent in terms of sine, cosine, and cosecant. Okay, now the first thing I'm going to do is I'm going to rewrite sine as the cosine over, cotangent over the cotangent is equal to cosine over the sine. And the cosine is equal to the square root of 1 minus sine squared over sine.
Wait, I thought 1 minus sine squared theta would be equal to cosine squared theta.
Okay, take that off then. Just 1 minus sine. There we go. How's that?
The property works the same then, even
Yeah.
Okay.
Mm-hmm. So it should be 1 minus sine over 1 minus sine squared over, no, it's sine squared. See, this question just doesn't work right because the way they've got it, it's just not right because the Pythagorean theorem is sine squared plus cosine squared is equal to, so that is squared. But they didn't say, so cosine squared, no, I took the square root. So that's why it's cosine. So,
okay, that makes sense.
you can do sine squared plus cosine squared is equal to 1. Cosine squared is equal to 1 minus sine squared. And then to make this cosine, take the square root of both sides.
Yes, sir. That makes sense.
Okay.
Thank you.
So that's your answer. All right. And then they want it in terms of cosine. All right. And if you want it in terms of cosine, you can rewrite cotangent. Rewrite cotangent as the cosine over the sine, and then just instead of manipulating the cosine now, you got to manipulate the sine. And that's going to be cosine theta over 1 minus cosine squared theta square root. Now multiply by not the conjugate, but the square root of 1 minus cosine squared theta over 1 minus cosine squared theta. I'm getting rid of the radical in the denominator. And that's going to give me cosine times the square root of 1 minus cosine squared over 1 minus cosine squared theta.
I have a quick question.
Yes.
So when it asks us to write, let's say, cotangent in terms of sine, cosine, and cosecant, so that means we have to change all of the, like, what's the word I'm looking for? All
Identities?
Yes, sir. All of the identities in terms of the
Whatever
sine and
identity
cosine?
you need, or
Okay.
whatever term you need. Yes. So
Okay,
you may
thank you.
go through and just change it one time, or you may change it 2 or 3 times. In fact, there's one that I did 2 of these. There's one that I did a reciprocal of a reciprocal of a reciprocal. You'll see in just a minute. Okay. So you may change one and then boom, you got it. And then there's others that you have to put 2 or 3 in there. So this one right here is easy. Using your Pythagorean, what is the cosecant equal to? 1 plus the cotangent. So the cotangent, if I'm going to write the cotangent in terms of cosecant, that's pretty simple. Cotangent is the cotangent is going to be equal to square root of cosecant squared minus what? So I just wrote cotangent in terms of cosecant. Now that's one that's real simple. Just use the Pythagorean identity. Now here's the one that I did, and I did 2 of these because I think everybody in the class sent this question in. I think there was like 10 questions with this question. And I don't fuss at y'all for that because I don't like the question. I don't like it at all. I don't like the way it's written. I mean, they just give you a box and they say rewrite like the top of the box. And I'm like, that's really not a good math question. Looks like somebody that was working for the book company decided to write it, not a mathematician or not a math teacher. This one says rewrite cosine in terms, and the ones that are missing, A, cotangent, I'm sorry, hold on, sine, B, cotangent, and C, cosecant. All right, now I want you to take a minute and look at all the different identities that have anything to do with cosine and sine, cosine and cotangent, and cosine and cosecant. Now the first one is real simple. Take your Pythagorean identity, sine squared plus cosine squared is equal to 1, and solve it for the sine. Okay, so sine squared is equal to 1 minus cosine squared, square root, sine of theta is equal to 1 minus cosine of theta, cosine squared of theta, and square root. Now that one's pretty simple. I'm going to go down to cosecant because it's pretty simple. I'm going to rewrite the cosine. Wait a minute, cosine. Oh, wait a minute, I messed up. Rewrite cosine in terms of, so I went backwards. I'm sorry. Oh, shoot. I did the opposite. I'm sorry. See, that's why I don't like this question. I'm just going to do it like this. Rewrite cosine in terms of sine. That's the way it's supposed to be written. All right, I'm going to rewrite cosine in terms of sine. The sine squared plus cosine squared is equal to 1. And I want cosine to be on the left. So I'm going to write cosine squared is equal to 1 minus sine squared, and take the square root. So the cosine of theta is equal to 1 minus sine squared. All right, that's the first one. The third one is I'm going to rewrite cosine as the cosecant. And the first thing I'm going to do is I'm going to solve my reciprocal identity, not my reciprocal identity, but my quotient identity. Okay, I'm going to switch it to the cosine is equal to cotangent times the sine. So the identity cotan of theta is equal to cosine of theta over sine of theta. I'm going to solve that for the cosine because that's what I'm solving for. Okay, so I'm going to multiply by sine, So the cosine of theta is equal to the sine times the cotangent, or the cotangent times the sine. Now I can rewrite both of these in terms of the cosecant. The cotangent is the square root of cosecant squared minus 1. And the sine is 1 over the cosecant. And that's your answer there. And you can rewrite it as the square root of cosecant squared theta minus 1 over cosecant of theta. Sorry. Okay. Okay, now this one, the second one, I had to actually work on it because it doesn't hit you in the face like some of these other ones. Okay, the third one says to write, the second one says to write the cosine in terms of cotangent. To write the cosine in terms of cotangent. Well, the first thing I'm going to do is I'm going to remember that cotangent is equal to the cosine over the sine. And I'm going to solve. I'm going to multiply by the sine on both sides. Let me put that in. Let me highlight that because I don't want you to think. Okay, I'm going to multiply by sine. There we go. You know I'm multiplying by sine would make it pink. This is the actual identity right here. And cosine is equal to sine cotangent. Now see, I've got one cotangent right here. So I'm good there. I just got to get that sine. I got to write it in terms of cotangent. But right now, there is no sine to cotangent. So I've got to find something else. So I'm going to change this sine to 1 over cosecant times cotangent is equal to cosine. Now we know that the cosecant can be written in terms of cotangent. So I'm going to rewrite this as 1 over the square root of 1 plus the cotangent times cotangent over 1 is equal to the cosine. And that's going to give me the cotangent of x over square root of 1 plus cotangent of x. Now I'm just going to multiply by the square root on top and bottom. And that's going to give me cotangent of x times the square root of 1 plus the cotangent of x over 1 plus the cotangent of x. Oh, squared.
Would they be squared? Yo.
Yeah. Sorry, squared. Now, you see what I did there is let me highlight this one because I need to show you that sometimes here is your original they call it quotient identity right there. There's the original quotient identity. And then I solved it, and I got cosine is equal. Then I couldn't find a transition from sine to cotangent. So what I did is I switched the cosine, or the sine to 1 over the secant, 1 over the cosecant, because there is a relationship between the cosecant and the cotangent. And there it is right there. And that's supposed to be a square, sorry. Sometimes I forget to write stuff, I'm sorry. And that should be a square here, should it not? Yeah. So I had to switch, not with one reciprocal, but I had to revert to a second reciprocal identity, a quotient identity, quotient identity and a reciprocal identity, just to get it to go back to cotangent. Like I said, they're just like the Rubik's Cube. They're just like a puzzle. You don't fix a puzzle the first time you try it. You have to work with it. You have to do it over and over and over. Okay, this next question, there's one question that had like 25 parts, and I'm like, really? You're really going to make this a 25-part question? And I think either this is it or the next one. I can't remember. It's the one that looks like a book. Well, that's the last one. So here's one. This is a verification. This is the ones I like to put on the test. Verify. My son's birthday was Sunday. I forgot to. The terrorist that I am, what do I buy him? He's 14. What do I buy him? A gun.
What kind?
I bought him a .22 rifle. He's been shooting my 9mm and my .45 and my shotgun and my other guns. And he wanted one that he could shoot, and he wants to get ready to go deer hunting and shoot, a rifle. I said, well, you gotta learn how to shoot a rifle first. And so I've got him a .22 rifle.
Do y'all shoot skeet?
Huh?
Do y'all shoot skeet?
He likes to shoot ski. I don't. That's what he shoots the shotgun with. He shoots it. I throw them and he shoots them. I don't care nothing about shooting them, but I shoot every once in a while. But I just don't. We just, he likes it, but I don't. But yeah, so I figured I'd make him a terrorist, a deplorable terrorist, and I bought him a gun. It's amazing though, knock on wood. He's been around guns for all his life, and he's never got shot with one. I don't understand. I don't understand that. Okay, so anyway, it says verify, and here I'm gonna write down the whole thing, and it's cotan of alpha over sine of alpha minus 1 plus cosine of alpha over sine of alpha plus 1 is equal to negative tan of alpha minus secant alpha cosecant alpha. And of course, what should y'all do? Before you even start, you should what?
put it into terms of sine and cosine?
No, I was going to say quit.
Pick a side.
I was going to say quit.
Ah.
Thank you, Miss Holcomb. I hope you wasn't being sarcastic, but I do. I buy my kids guns all the time. My daughter's got guns too. All right. I see something different. You know what I see? I see shortcut number 2 on the bottom. That's what I see. I'm going to highlight that because that looks like that's shortcut number 3. A plus B, A minus B. Of course, y'all don't want to hear that, do you?
We'll listen to it.
What?
I said we'll listen to it.
All right. So I'm gonna focus on this side because this is the most complicated. So first thing I'm gonna do is I'm gonna get a common denominator. And I'm gonna convert the numerators. Now y'all know how to do that. I mean, you've been doing that in algebra for I don't know how long. So I'm going to get a common denominator of sine alpha minus 1 times sine of alpha plus 1 plus sine of alpha minus 1 times the sine of alpha plus 1. Now let's convert. How many times will sine minus 1 go into this?
One time.
One time.
Sine plus 1 times. So cotan times sine plus 1. How many times will sine plus 1 go in this side? Sine minus 1. So now we got all of this over the common denominator. Common denominator, I'm going to make it 1. Sine alpha minus 1 times sine alpha plus 1. And then up here, hey, I can write cotan. I can write cotan as what? How can I rewrite cotan?
Cosine over sine.
Cosine over sine, do it. Cosine alpha over sine alpha times sine alpha plus 1 plus, you're really not going to do anything with this, cosine alpha times the sine of alpha minus 1. All right, go ahead and work on this right here. Distribute that cosine over sine. And go ahead and distribute this Yeah, I guess you could call me a real deplorable, what do you call it? Deplorable, irredeemable. And of course, several years ago, I was considered, since I'm an NRA member and a veteran, then I'm a terrorist. So. Miss Holcomb, do you have a pink gun? My daughter has a pink gun. Okay, so that's going to be, I'm going to put a baby step in here. I have a purple one. All right, so I'm going to put a baby step in here. Cosine of alpha over sine of alpha times sine of alpha over 1 plus cosine of alpha over sine of alpha plus cosine of alpha sine of alpha minus cosine of alpha. Now I'm going to put all that over a squiggle. I'm not going to write that denominator 15 times. Okay, that little squiggle, that means denominator written. Denominator, you're not going to do anything. All right, now what happens to that sine? What happens to these two sines? They cancel, and that leaves you with what?
Cosine.
And what happens to this cosine and this cosine?
They are going to add up.
They're going to cancel too. So I'm going to kind of put a cloud over this. And those two cancel. So now you've got, let's write what we got down now. You've got cosine alpha over sine of alpha plus cosine alpha sine of alpha over sine alpha minus 1 times sine alpha plus 1. Now that bottom, remember that bottom right here can be written a plus b, a minus b is a squared minus b squared, which will be sine squared minus 1. So cosine alpha over sine of alpha plus cosine of alpha times sine of alpha over sine squared minus 1. And what is the sine squared minus 1? What is that?
Cosine squared.
Cosine squared. Technically, it's negative because the signs would be different. It'd be negative sine squared plus 1. So it's going to come out to be negative cosine squared. That's not a big deal. But that's going to give us cosine alpha over sine alpha plus cosine of alpha. I'm sorry. I done messed up. Cosine of alpha, sine of alpha over negative sine squared. Negative cosine squared. Shoot. Negative cosine squared alpha. Now I'm going to put this one over the common denominator and this one over the common denominator. So cosine of alpha over sine of alpha divided by negative cosine squared alpha over 1 plus cosine of alpha sine of alpha over cosine squared alpha. Now, when you divide by a fraction, you multiply by the what?
Reciprocal.
By the reciprocal. So that's going to be 1 over cosine squared alpha. And the cosine is going to cancel this with this. And that's going to give me negative 1 over sine cosine. Let me use my green black pen. That's going to give me negative 1 over cosine sine minus sine over cosine. And what is the sine over cosine?
Tangent.
And what is 1 over the cosine and 1 over the sine? 1 over the cosine is cosecant. And 1 over the sine is what?
I think you actually said that backwards.
1 over the cosine is the cosecant. Okay.
It's the secant.
Yeah. Okay. Yeah. So see, I got it backwards. Sorry. Anyway, that's secant and cosecant. Thank you. And that's what we started with. Negative secant cosecant minus tangent. So like I said before, if you like puzzles and you like fooling with puzzles, then you're going to like these identities because that's what you're doing. You just keep turning the puzzle and keep turning it until you get it. If you suck at puzzles, you're going to have to really work hard to get these identities. Question, right, complaint. All right, now A through E. I looked at this question and I looked at it and I went, you have got to be kidding me. It's got like 35 parts. Y'all know which one I'm talking about?
The one on 10.3.
I think. I don't know. It's supposed A or B are angles in standard position. Wait a minute, there's a short one. This one isn't too bad. Another verify. This one's short. Verify. 3 cosine theta minus 9 sine theta squared plus 9 cosine theta plus 3 sine theta squared equals 90. Y'all are going to love this one. Now, of course, we're not going to pick the 90. We're going to pick the left-hand side. We're going to pick the most complicated. And somebody tell me what we have on the left-hand side.
Terms of sine and cosine.
Nope. Good try, though. This is shortcut number. This is shortcut number 2. And this is shortcut number 3. Change them into polynomials. Yeah, I'm sure y'all wanted to hear that, didn't you? Okay, it says somebody sent me a chat, but I don't see it. Oh well, I guess it's a I don't know. Y'all ready to change them into trinomials? 9 cosine squared theta minus 54 sine theta cosine theta plus 81 sine squared theta plus 81 cosine squared theta plus 54 sine cosine plus 9 sine squared theta. So I just did shortcut number 2 and shortcut number 1. Now, what happens to these two guys?
They cancel out.
They cancel out. Good job. Red pen. So that's going to leave me with, I'm going to group them together with the coefficients. So that'd be 9 cosine squared theta plus 9 sine squared theta plus 81 cosine squared theta plus 81 sine squared theta. Factor out a 9 here. That leaves you with cosine squared theta plus sine squared theta plus 81 cosine squared theta plus sine squared theta. And what's cosine squared plus sine squared?
One.
And what's 9 plus 81?
90.
It's a miracle. I wish my remote control reached into my den. Somebody on TV right now that I can't stand listening to.
I have a question.
Yes.
How did you get 54? Like, where did that number come from?
Shortcut number 1 and number 2. I tell you what, recite number 1 to me. A plus B quantity squared is equal to what?
A plus
People can't recite shortcut number 2 and number 1. You know why? Because they still haven't learned it. Shortcut number 1. There went my remote. A plus B quantity squared is equal to A squared plus 2AB plus B squared. A minus B quantity squared is equal to A squared minus 2AB plus B squared. Who asked that question?
me.
Okay, Miss Harbert. Where did the 54 come from? Can you see it now? What's 9 times 3? That's for everybody. What's 9 times 3?
27.
And what's 27 times 2?
Got it.
54.
54. You got to use shortcuts. Okay, I'll go through it one time, okay, because y'all should know this. 3 cosine theta minus 9 sine theta quantity squared. This is shortcut number 2 because it has a minus sign. A is equal to 3 cosine theta. B is equal to 9 sine theta. Plug and chug. Parentheses squared minus 2 times parentheses plus parentheses squared. That's this right here. 3 cosine theta. 3 cosine theta. 9 sine theta. 9 sine theta. 2 times 3 is 6. 6 times 9 is 54. Now you see it, Miss Harbit?
Yes.
You got to get the rust off those shortcuts. And are you the only one that are rusty? No. I have a whole college algebra course, college algebra class. They're rusty. I have to remind them. The shortcuts have to be with you at all times. You can't just regurgitate them and forget them. And if you're in engineering or science and y'all are in business, you're going to see the shortcuts up until you finish your math. So for y'all, that'll be 230. Some of y'all 130, but 230, it goes all the way to 230. And if you're in engineering sciences, they go all the way up to DiffEq, differential equations, and physics 1 and 2, and statics and dynamics. Okay? All right, here's the marathon. Now, does this, no, it doesn't take this long to do this problem. Here's the problem. It says, I'm looking to see what time class is. Okay. And they give you this. They give you cosine of A is equal to 15 over 17. They say the cosine of B is equal to 4 over 5. And they tell you that A is in the first quadrant and B is in the first quadrant. And they want you to find A, they want you to find sine of A plus B. They want you to find the sine of A minus B. They want you to find the tan of A plus B. And they want you to find the tan of A minus B. And the quadrant of A and B and the quadrant of C and D, I think. I can't remember. No, the quadrant of A plus B, E, is the quadrant of A plus B. And then what is the quadrant of A minus B? Now that's the question. Now, each one of these is a test question. So I would not give you this whole question on a test. Okay, I would give you these parts because these are each good, except for the E and F. I really don't care about that. A, B, C, and D are good test questions. All right. Now, while I go in there and turn off that TV before I go crazy, I need y'all to start working on it. I can only listen to so much crap. That's why I had to turn it off. Okay. Now, first thing you do on this problem. First thing you do is find your way. How many times have I told you? Trig, a lot of times you need to find out where you're at. Okay? So I'm just going to pull this to the side. And I'm going to rewrite what they give us. And we're going to find out everything. Cosine of A is equal to 15 over 17. Cosine of B is equal to 4 over 5. Now, if you have this cosine of something, what can you do to find out where you're at? What can you do with the cosine of 15 over 17? Anybody?
Make a right triangle.
Good. Make a right triangle because you know that the trigonometric functions are for right triangles. And what do you use for right triangles when you want to find something? What do you want? What do you use?
Pythagorean theorem.
Pythagorean theorem. That's right. So I'm going to draw a right triangle here. And I don't care about scale. This one's smaller, so I'll make it smaller, okay? Okay. What is the cosine?
Opposite over adjacent.
Opposite over adjacent. Oscar had no.
No, I'm sorry.
Adjacent over hypotenuse.
Yeah, my bad.
Okay. So that means that our adjacent is 15 and our hypotenuse is 17. Here is 5, and here is 4. So I'm going to call this O and O. Opposite is equal to the square root of 17 squared minus 15 squared. Opposite is equal to the square root of 5 squared minus 4 squared. Opposite is equal to, I did 17, I done did it. How much is it? 17 is 289 minus 225. Opposite is equal to the square root of 64, which is equal to 8. And we're going to take our handy dandy purple and we're going to put an 8 right there. Yeah, you can't even tell it. I'm going to color that orange. There we go. So that one's 8. And this one, opposite equals square root of 25 minus 16. Opposite equals square root of 9, which is equal to 3. And our green highlighter is going to give that a 3. Now are we doing? No. We got to find the sine and the tangent. So we go down here and we say, okay, if the cosine is equal to that, what is the sine equal to? Oscar had 8/17. And the tan. Oscar had a hunk of apple, 8/15. Sine. Oscar had 3/5. Of apple, tan is equal to 3/4. And all of that you learned back in Unit 1. Okay, now I'm going to rewrite my question. And I'm going to say, first, before I write the question, I'm going to do cosine of A is equal to 15/17. Sine of A is equal to 8/17. And tangent of A is equal to 8/15. Cosine of B is equal to 4/5. Sine of B is equal to 3/5. And tan of B is equal to what? 3/4. Now what? Now I'm going to fold this up. Get your cheat sheet out. The green cheat sheet that one or two of you printed out. Because I know about half of y'all didn't print it out, but some of y'all did. Plug and what? Plug and chug. So go ahead and do that for A, B, C, and D. I don't care about E and F. Plug and chug into A, B, C, and D. You got to have your cheat sheet. I'll show you the first one, and then y'all can finish this one for homework. So, the sine of A plus B. The sine of A plus B is equal to sine, cosine, cosine, sine. Sine, cosine, cosine, sine. And you add. Now, of course, we read from left to right. This is A to B, left to right. And this is A to B, left to right. And this is A to B, left to right. Plug and what? Plug and chug. 8/17. Cosine of B is 4/5. Cosine of A is 15/17. And 3/5. Now, I'm sorry, folks. Is that easy or is that easy? You'd be surprised on how many people are lobotomized on this question. All you got to do is find your way. You got to do that first. Then you use your cheat sheet and plug and chug. And basically you're going to, you know how to do this. And you should get 77 over 85. Now, how many of you saw this question in your homework and said, I have no earthly idea how to do this? Raise your hand. Just one person? Come on. Okay, now, now, those people that raised your hand, how many of you know how to do it now? Well, you're supposed to take your hands down, but that's fine. You just find this first, take your cheat sheet and plug and chug. Don't you feel better about yourself now? All right, that's good enough for today. My head's hurting. I don't think I didn't get to my, I got to my 10.2 questions. Those were, I think those were, weren't those all 10.1 questions? I believe they were. And nobody's going to talk to me.
I think they were too.
Yeah, I think they were. So we'll go over 10.2 and 10.3, and I'll go through the homework questions, and I'll pick out the most sent and the most relevant, because I'm going to tell you, if I'd have gone over each one of those questions and the repetition, we would have never got through today. We would have never got through as many as we did. Okay? Question, great, complaint.
Quick question.
Yes.
So how should we find the quadrants of A plus B and A minus B?
Well, the quadrant, you're going to get negative answers and positive answers.
And that'll determine the quadrant?
Yeah, negative, hold on a second, let me find my problem. Since the negative, now remember, hold on a second. I have to look at the problem. A plus B is going to be in quadrant 1 because your sine and your cosine is positive. And when you get to your negatives, I think the tangent is negative. Let me look. The tangent is negative. All students take calculus, so it has to be in quadrant 4. Because it can't be in quadrant 3, because it can't be in quadrant 1. So it has to be between 2 and 4. And the way it works out, I think both, let's see, the tangent, yeah, the tangent is negative. And that's what throws A minus B. The tangent of A minus B is negative. So it throws both the A minus B's. It throws them into quadrant 4. So it all depends on when you get a negative or not. Do the math with the fractions and you'll see the negatives pop up. Does that make sense?
Thank you. Yes, sir. Thank you.
And I think you're going to see a negative. Yeah. Because with the tangents, you have to subtract. Yeah, the sine of A minus B, you're going to get a negative also. So since okay, let me just show you this. Since the sine of A minus B gives you a negative, and the tangent of A minus B gives you a negative, then you can't be in quadrant 1. You understand that? Hello? Mr. Michelle, do you understand that?
Yes, sir. Sorry, my microphone wasn't working.
Oh,
for a
that's all
second.
right. Okay, now, what quadrant is it in? Well, it's in the only one that has sine and tangent negative. All students take calculus. What quadrant do you have the tangent and the sine negative?
1 and 4.
No, 1 is
Or
positive.
excuse me, just 4. Quadrant
Just
4.
4 is the only place that the sine is negative and the tangent is negative. And that's what you have. And you'll see that when you do your math, you'll see that they come out negative. All right, let me call the roll or do the roll and get y'all out of here before somebody fusses.